Hello guys, this is Lisa from Daily Life Engineering. Today I will show you how to measure moment of inertia of a structure. I will show you for a beam. At first, let's see what is moment of inertia. Moment of inertia is the name given to rotational inertia, the rotational analog of mass for linear motion. It appears in the relationship for the dynamics of rotational motion. The moment of inertia must be specified with respect to a chosen axis of rotation. For a point mass, the moment of inertia is just the mass times the square of perpendicular distance to the rotational axis. First, we can express it as I equals to mr square. I is the moment of inertia, r is the distance to the rotational axis, perpendicular distance, and m is the moment. Let's introduce to the term. If we want to derive the bending stress, then we will get sigma equals to my divided by I. Whereas m is the moment in the beam, y is the distance from the centroid where I want to find the stress in, and I is the area moment of inertia. Okay, let's see. We will use parallel axis theorem. So the terms parallel axis theorem is the parallel axis theorem is used to find moment of inertia of an area about any axis that is parallel to an axis passing through the centroid and about which the moment of inertia is known. Here I have done a pretty mistake. It will be cube. Okay, you can solve it out, right? Here is a mathematical problem. We will solve this out. All this scaling is in millimeter scale. So let's check that. At first, I will, if we consider this point according to this line, or this portion and this portion is symmetrical to each other, right? So I will take rectangles A and D at first. So I will derive Ix. I mean this and this rectangular moment of inertia for x-axis according to the x-axis. So at first I am taking I bar x cube plus a dy square. This is the conventional way of deriving the moment of inertia for a rectangle. 1 by 12 bh cube actually. bh cube. So here according to the x-axis, this is the base for this rectangle. So base is 100 and the height will be, I told you, bh cube. So b will be the base and h will be the height. Height is here is 300. So I have put 300 cube plus this is the area. I mean the area equation of deriving of a rectangle is width multiply height. So width is 100 and height is 300. So this is the area A, and the y according to the y-axis, the distance of the centroid. So the distance of the centroid from here, why we are taking this from here? Because this is the neutral axis for this whole structure. Okay, so I am taking distance from this point until this point because this is the middle point for this rectangle. Okay, so I am half of 300 will be 150 and half of 100 will be 50. The summation of 150 and 50 will be 200. I have put 200 and square of it. Here we have result, and I will measure again the moment of inertia according to the y-axis. So again the A and D rectangle, again for the A and D rectangle. So at first take the conventional method, 1 by 12 bh cube. So here base will be 300 because you are taking according to the y-axis. So y-axis will be base and this will be the height. So 300 into 100 cube plus the area will be same always, 100 into 300. Why are you taking 250 here? Just because the point is here and you are taking dx. I mean the centroid from this to this. We know the whole length of this rectangular bar is 600, and this is covering 100 and this is covering 100. So keep this aside, and this is 100, right? This is the middle point of 100, so it will be 50, and this portion will be 50 and this portion will be 50. So this will be 300. Half of 600 will be 300, and we will deduct 50 from 300, so we will get 250. Here it is, and let's calculate it. Again, we will calculate for the rectangle D. Why haven't we take a dy square or a dx square term here? Because this is the rectangle where the neutral axis exists. So we won't take this term here. So we will take only the conventional method of deriving moment of inertia for a rectangle, 1 by 12 bh cube. So here b is the base according to the x-axis. The base is 600 and the length is 100. So 100, I mean height is 100. So 100 there will be cube. So this is the result, and according to the y-axis, this will be the base. So base will be 100 and the height will be 600. And always there is a cube with the height. So here is our result. Let's summation it. This term ix and this ix will be summation will be added, and this iy term and this iy term will be added. So here we have got the result, and this is the moment of inertia of ix according to the x-axis and according to the y-axis. So that is our problem. If you have any more problem for any structure, you can let me know about that. I will try to solve that out. And thank you for watching, and have a good day.